All right, for number 7, I had to resize the window here for the point of where the graph goes here. So we have 3.6, and we have a graph that looks like this. So this is number 7. Let's go ahead and do the work for it here. Let me copy it onto a little palette where I can work from. All right, so let's go for it here. In order to graph f of x, x squared minus 3, what we need to do is make a little table. And so we go with f, or actually x, and then if you want to, you can make this an extended table. An extended table, what that happens is that we do the work here. We do the work in the middle, and whatever the work tells us, we put at for the y value. So let's just plug in a 0. Let's see what happens here. If you plug in a 0 to this function, you get 0 squared minus 3. Well, square 0 is still 0, minus 3 is a negative 3. So then we'll plug in a positive 1. If you plug in a 1, 1 squared is 1, minus 3 makes a negative 2. Plug in a 2. 2 squared is a 4. Subtract 3 makes a 1, and then we got to keep on going here. And usually with parabolas, notice that it's a parabola because of this little 2 right there. We probably should put a negative 1 into it and negative 2, just see where we're at. So if you square negative 1, becomes a positive 1, subtract 3 makes a negative 2, and you plug in a negative 2. Let's see what happens here. Negative 2 plugged in. Notice how you have to put parentheses now. Negative 2 squared is a 4. 4 minus 3 is a 1. Okay, we call this a symmetric. Parabolas are always symmetric. You can kind of see this because notice the repeating of the y values here. So I'm going to sort of just graph it on the sheet of paper. We'll transfer it over to the graph in just a bit here. One little word of note here as soon as I graph this here. So 0 and negative 3 is my first point. 1, negative 2, and then 2, positive 1. So check, got that one, got that one, got that one. Negative 1, negative 2 is going to be my next one, which is this one. And then negative 2, positive 1 is the last one. So I'm going to graph something that looks like this. Oh, sorry, I moved the graph here a little bit here. Okay, so there's that little graph at least. Okay, one little note here. When you're going to click this parabola right here, you're going to have to put in a certain particular point as your first point, and it's this point right there. It's the sort of the middle point of the graph itself. And so if you look at this here, it's this point right here that you got to do first. And then you could do another point whatsoever, this point, but you got to do that big dot first, because that's the way you graph parabolas on this particular graph. When you graph absolute values, notice one of the points have to be that little vertex point there. Okay, so we got first parts done. Now we're going to graph the line x equals 3. Now x equals 3, you should automatically know this guy is a vertical line. That is a vertical line. And so for to graph it, let me graph it in a dark color here. That's a vertical line. 1, 2, 3. Positive 3. So 1, 2, 3 right here, right at the positive 3 marker here. So we're going to go out 1, 2, 3. So it's this point right here. Now on the little rough graph that I just made, I noticed there's no point of intersection right here. These two lines have to interact somehow, because that's what this point means. I want to know when this point, if I plug in a 3 into my function, what's the function going to be at 3? So here they don't touch, so I wonder as I graph this what's going to happen. So let's go back to the problem itself. Let's see what we can do. Alright, so here we are. We're going to have to select the parabola function. Notice that becomes a little darker gray. And again, I said the first point we have to graph is that little, it's called the vertex point. That's the first point needs to happen. If you go straight out, it looks like a straight line. That's not true. That's how you do it. You can get this little curve. And if you kind of curve down, that's cool. But again, it's this little middle point. We call it the point of symmetry. That's what we want. So it doesn't really matter. You can plot 1, negative 2. You can plot 2, positive 1. Notice they're going to produce the same exact line, so it doesn't really matter which way we go. I'll just do that dot. Okay, and then we've got a graph x equals 3. Now that's going to be a straight up and down vertical line, goes through 3, 0, and then just goes straight on up. All right, I messed up a little bit here. Let me try this over just real quickly here. So parabola comes down this point and this point. Then I got to switch it to a straight line over here. That's what I forgot to do. Switch it to a straight line over here. And then it goes through 0, x equals 3, and then goes straight up. Hey, this one is actually crossing. It crosses right here, and that's what this all means right here. 3 comma f of 3, which means where did this line cross? Across right here. Now for that, what you got to do is you got to click on this little dot right here. Dot, and it becomes this little sort of big blue dot right here. Okay, let's see if I got this right. Click submit. Boom. All right. There it is. So I got them all full credit for that.